So imagine that you have a system, again, of 3 nodes, of 3 buses. We have a generator connected to the node number 1, a generator connected to the node number 2, and there is a third node. There is only one demand, which is at the node 3. The voltage in the node 1 is given by 1 per unit and phase angle equal to 0. So this is, for my system, this will be the slack. So I'm fixing voltage magnitude and voltage phase angle. Additional information, node 2, I know P and I know V. So it means like this is a PV bus. So this is classified as PV, this is already a slack. And then the last, then I know like what is the active power and this is reactive power. I'm giving you already this information with sign of minus. Minus means like this is a negative injection. So this last bus can be classified like a PQ bus. We observe as well like these values of power are close to 1 because we have transformed everything per unit. The power base is 100 megawatts. Finally, the characteristics of the grid is given by this impedance, and this impedance. You see here there is only just one number, so it means like we are considering only a series element. There is no shunt elements for this line. Okay, the first thing they are asking us is to calculate what is the admittance matrix. What is the side of this admittance matrix? It will be 3 times 3. What are the values of the non-diagonal elements? In this, we will have minus y series that go from 1 to 2. And this value is minus 1 over 0.01 plus j 0.1. So if you do that, so you have 9.95 and there is an angle related with this complex number 1.67. While you see the symmetry of this system, so I have the same value for here, in here, in here, and in here. Then I need to compute what is the diagonal elements. I have only series elements, so I have not any in shunt. It will be easy. I just need to sum up what are those elements of the same row or the same column and change the sign. Okay, I have the same for the others. So I have already my admittance matrix. The next thing I've been asked for is to write what are the power flow equations. Okay, let me start writing power flow equation for the active power flow. So I recall what is power injection in one node. It will be equal to this voltage in this particular node, I, plus the summation for all nodes going from 1 up to n of the voltage at those nodes times the element of the admittance matrix ik times cosine of the phase angle of particular node I minus phase angle of particular node k minus the angle related with the complex number ik of the admittance matrix. So I can start writing the equation. So for the first one, I don't know what are the production, what is P1 and what is Q1, so they are unknown. For the second, I don't know what are the Q2 and I don't know what is delta 2, they are unknown. And in the last one, I don't know what will be the voltage and the phase angle. So this is the hardcore method. I know you can use computers, but we are going to do for one time in this hardcore way. So let's start for node 1. So the power, active power in 1 is equal to voltage in 1 voltage in 1 is always 1 times the summation of, well, K will go, in this case, K can go from 1, 2, and 3. So when K is equal to 1, so I have voltage in 1, this is 1, element Y 1, 1, cos of delta 1 minus delta 1 minus theta 1, 1. Yes, this is related for K equal to 1. Yeah, by replacing, so this is 19.9, this is 0, and this is 1.47. Then I have plus 1, which is this voltage. Yes. And then multiply by, I have to multiply by this when K is equal to 2. Okay, voltage in 2. How much is the voltage in 2? Well, it's already fixed, 105, because it's a PV bus. This is 105 times element of the admittance matrix 1, 2, times cos of delta 1 minus delta 2 minus theta 1, 2. Yeah, this element is 19.9, and I'm replacing inside here. Delta 2 is not known. I have no information of delta 2, it's a variable, it's an unknown. This one is 0, so I have this element. Well, I will replace this cosine, is cosine of minus delta 2 minus 1.67. And then I have plus, again I have B1, which is 1, times this thing for K equal to 3. Okay, for K equal to 3, voltage is not known, so it's 3. Element Y3 is equal to 9.9. This is, this previous thing is 9.95, like this one. Cos delta 1 is 0. I don't know delta 3, and element of the admittance matrix is 167.
Finally!
Okay, so you see the dynamics of this. So I just write an equation that have one variable here, P1. All of this is a number. All of this is number. And then I have another variable here, delta 2. I have another variable here, the V3, and there is another variable here, delta 3. You see how complicated it is writing this thing and how easy it is to make mistakes. So it's better to rely on computers and to automatize this thing. This is for node number 1. I can do for node number 2. Well, I wrote the question for you for node number 2 and node number 3. We see like in node number 2, we know all the injections. Remember, we know all this active power injection, which is positive. Number 3 is negative. And you see, well, delta 2 again, B3, delta 2, delta 3, V3, delta 3, and delta 2, delta 3, and B3 is appearing as decision variable. We can continue working with the set of reactive powers equation in a similar way. So I'm giving you the definition of reactive power for every node. Now I'm going to write the equation for each of these 3 nodes. And finally, if we write the equation for each node for the reactive power, so we have for the first one, we don't know Q1, and we still have some efficient variables that are relating with delta and 2 and 3 and V3. So they are the same variable that appears in the previous definition of the reactive powers. So we see like Q2 is new decision variable, delta 2 is already in there, delta 2, delta 3, V3, V3, delta 3, delta 3, and delta 3. So you can see this is a set of 3 constraints, another 3 equations, and if you sum up, I have in total 6 variables. Let me go back. I have 1 variable, 2 variables, 3 variables, 4 variables, 5 and 6. So this is a system of 3 equations and 3 variables that we can solve. So this is the solution for the 3 nodes. With these 3 phase voltage, I can compute anything. Straightforward. So observe like this was fixed and this also was fixed.